Hello, I'm Benjamin Kessler, and I study the consistency among states in evaluating the risk of non-native plants. Invasive plant species are a threat to ecosystems and economies. Countries and states use weed risk assessments to identify and prevent new invasive species, including invasive species that could shift into the region with climate change. But these evaluation processes, referred to as weed risk assessments in my study, vary widely among different countries and states, and may not allow for the consideration of plants arriving with climate change. Therefore, I examined the weed risk assessment processes of 30 US states to test whether they meet minimum standards for weed risk assessment and whether they could include climate change. Invasive species are those that are non-native, in other words, not previously located in an area, that arrive into these new areas and cause damage. The left image shows Oriental bittersweet, a common invasive plant in the Northeast that can strangle the native vegetation. In the right image is Japanese knotweed, also common in the northeastern US, which forms densely packed populations that can prohibit important native plants from growing in the area. Weed risk assessments aim to prevent new invasive plants from being introduced and sold and spread, or to identify plants that are already problematic and should be managed to prevent further damage. On the right is a snapshot of the weed risk assessment for Massachusetts. The part I highlighted here shows the possible outcomes of a Massachusetts weed risk assessment, either invasive, likely invasive, or potentially invasive. It could also be given an unknown if the person doing the weed risk assessment is unable to determine the outcome. Climate change is resulting in lots of species moving into new areas in order to maintain their preferred climate conditions. This map shows the predicted increase in the total number of invasive plants throughout the US. Certain areas, such as the Northeast, have a high projected increase, but even the gray areas here are still likely to have new invasive plants in the future. This map just shows the net change in the total number of invasive plants. In these gray areas, the number of invasive plant species moving out of those regions is projected to be roughly equal to the number of new plant species moving into those regions. My goal was to analyze the weed risk assessments of US states. To analyze them, I used a list of minimum standards a weed risk assessment should have. This list of standards was developed in a paper by Roy et al. And this box down here is an excerpt from the paper that describes the consensus workshop, where 35 experts met to agree on what these standards should be. My first step in analyzing weed risk assessments was to get the weed risk assessments. I tried to find an assessment for each state on the internet, and for states where I couldn't find one, I looked on state websites for contact information so I could email these states asking for their risk assessments. So after obtaining WRAs, weed risk assessments, I determined whether they met the 14 standards from Roy's paper. These standards encompass the different phases of the invasion process, from their transport and introduction into a new area to their establishment and spread throughout the new area. This map shows, in green, the states that I studied. For the rest of the states, there is either no weed risk assessment or I just wasn't able to find one. So I studied 30 out of 50 states. This graph displays some of the standards along the x-axis and the number of weed risk assessments that met these standards on the y-axis. The blue shows the number of states that met the standards, and the orange shows the number of states that partially met the standards, but not fully. These 4 criteria, invasion history, likelihood of becoming invasive, species distribution, and impacts on biodiversity and ecosystems, were met or at least partially met by almost all 30 states. The reason it's 31 in some of these is because California uses 2 different weed risk assessments, so I did 2 separate comparisons for California. Some criteria were met by about half of states, like socioeconomic impacts. Other criteria were met by only a few states, like climate change consideration. To give an example of what it means to partially meet a criteria, likelihood has a lot of orange because many states meet some parts of this standard, such as likelihood of establishment, but states often do not consider the likelihood of introduction into the state, so they only partially meet this likelihood criteria and therefore are orange and not blue in the graph. Next to these check marks are states that are highly compliant and not so compliant with the standards. A potential drawback of having a thorough and comprehensive risk assessment is that it takes a lot of time to complete. This was something not considered in my study, but it's important for states to be aware of this when designing their weed risk assessments. Some ways that states could incorporate climate change include instructing people to work it into their answers to the assessment questions, or adding new questions to the assessment, and also removing anything from the assessment that prevents the consideration of climate change. Wisconsin was one of only 3 states that considers climate change, and this box at the bottom illustrates how it incorporates climate change into the weed risk assessment of Japanese knotweed. That concludes my presentation. I would like to thank everyone who helped me along the way, and thank you for listening.